So let me start our session today. We'll be back, to my surprise, when I see the person who is delivering the paper. So I should say, to my surprise, we'll be back at part of speech tagging and named entity recognition. And instead of neurological problems, we will be back to the down to the earth problems. So please, you have the floor.
Okay. Good afternoon. I am very glad that I can present two new taggers, part of speech tagger and named entity recognizer, which are developed primarily for Czech language, but they can be trained for any language for which annotated data exists. It is a joint work of me, Milan Straka and Jan Hajic, and these are our, you can contact us by these emails. Okay, so this outline and the web links you see here to the tools are pretty much what I would like you to remember from this talk. So in the first part of this talk, I will present a morphologic dictionary and tagger, which you can find here. In the second part, I will talk about a new named entity recognizer with state-of-the-art results for Czech. And in the end, I would like to say a few words about a second version of Czech named entity corpus, which was used for training the named entity recognizer. And it is a joint work of another set of authors, which are Magda Ševčíková, Zdeněk Žabokecký, me, and Milan Straka. And again, you can find all the information and download the corpus here. Okay. Now, you might ask, why would we bother making yet another part of speech tagger or named entity recognizer? We actually had many requests from both research community and commercial sphere, and our greatest motivation was that we needed a tool which would achieve state-of-the-art results in Czech, and also would be very well suited for rich morphology languages. From the commercial sphere, we often receive requests for a tool which would be an end-to-end application, not like a research prototype, but really a program which even people with very low or no linguistic background could use. And obviously, it should be extremely efficient in terms of word throughput and memory and disk usage and resource usage. And last but not least, but we wanted to offer interface in multiple programming languages like C++, Python, and Java, which were the most common requests, and the software should be free, open source. So these were our motivations, and you can judge throughout the talk if whether we accomplished them. So without further delay, I will present the Morphologic Dictionary and tagger. We strive to offer as much complete interface to morphologic tasks that people could need for their morphologic analysis, and even people from outside linguistic background. So the tool offers tokenization and morphologic analysis. That means for a given form, it gives you a set of possible forms and part of speech tags. It also does lemmatization and morphologic generation, which is kind of the backward operation. So for a given lemma and a tag, it generates the respective form. And most obviously, it does tagging, so it disambiguates for the sentence, it disambiguates the tags for all words in a sentence. You will not be surprised that it is based on a Czech dictionary, Morphlex, which which you can find here, and the tool is basically a programmatical interface above Morphlex. Okay. I would like, before I say something about how the tool was done and what it does, I will show you a quick demo. Okay, I have to go out. The tool does offer a binary, a precompiled binary, a library in C++, Python, and Java, and an online demo and a web service. And for the purpose of the demonstration, I will show the demo. I hope all works well. Okay. So, it is pretty much straightforward, so we can use some today's newspaper to get a sentence, and we can, okay, no, we don't want this. And I think the most straightforward application is tag. So we have a raw text and we want to tag it. If you don't provide any other options to the program, it will do tokenization. First, it will do segmentation for sentences, tokenization. It will provide the suggestion for lemmas and tags. Maybe we can see the pretty print. This is for a computer. And here you can see the results printed nicely. Okay, so this is a very quick demonstration, and if I have time left, we can try more examples which you can ask. So back to the talk. Okay, now I will say something about how the Morphologic Dictionary is implemented. Because I think that most of you here are linguists. You know that in the Czech language, the words take many endings, and for example, for some kind of adjectives, the adjective can appear with many tens of forms for the adjective, for the lemma. So these numbers are very much different from English. So for a path dependency tree bank, one finds 170,000 forms, unique forms in the corpus. So if we want to have a software which is fast, efficient, and very low in disk and memory usage, we need to handle the linguistic regularities somehow, so that we reduce the processing cost. And the way, actually I have this, and the way Morphodata achieves this is it finds a set of templates in which corresponds to the linguistic regularities found in the resource. So Morphodata needs a resource for the language which contains lemmas, forms, and tags. In our case, this was Jan Hajch Morphlex, and it does not need to know the language. It automatically creates a set of templates. I will now show on a few examples how it does so. So, when Morphodata finds for one lemma, it groups all its forms which it finds in the resource. And it builds a tree-like structure called tree, in Czech, in which one character corresponds to one node. And it is also called a prefix tree, which means all the forms share the same prefix, and this part corresponds to the forms and then it finds a very suitable, I will talk about this later, a suitable node which then serves as a common prefix, hrad, and the whole set of endings is one template. Okay. Next example is, so the next example shows two things. One of them is there can be more than one template, and there usually are, from the nature of Czech language, more than one template for a word. This word is brana, which appears as brana or brano. The prefix is brana. So we need two templates here, and one template is all endings which come with brana, and the others are those which come with brano. The second thing I want to show on this slide, the templates are obviously shared between words, so a similar word, morphologically, lipa and lipo, share these two templates, which results in a great reduction of resources. Okay, I have this. This example shows that some words or many words can have more than two, actually usually they have more than two templates. This is the word green, zelený. Okay. Yeah, there are no letters because they wouldn't fit in the image. Okay. So the original resource we were given contains over 1 million form tag pairs and over 4,000 tags, and it was huge. We created 7,000 templates, and the whole dictionary, so the whole Czech dictionary, was encoded using 3 million template instances. So 7,000 is shared, and 3 million templates is how there is overall. And in the end, the binary form of the dictionary uses 2 megabytes. Okay. Now, this was the Morphologic Dictionary, which provides morphologic generation and morphologic analysis, and how part of speech tagging is done. This is a re-implementation of Spoustová, of a research by Johanka Spoustová in 2009, and it is a supervised rich feature average perceptron. So I refer for this paper. The paper presents both supervised and semi-supervised methods, and we only use the supervised part. Okay. This is the evaluation. The tagger was of the part of speech tagger. The tagger was trained on Prague dependency tree bank on the training section and tested on the test section. We experimented with the thought that we could train it on both the training and development section, but then our research fellows usually need the development section for tuning their own tools, which so we could use only the training portion. And the results are of Morche, which Morche is an implementation of Johanka Spoustová. Featurama is a research which was here but is not available with the models outside of the institute, and Morphorita is the new implementation. And the results are very similar because they are all implementation of the supervised part of Johanka Spoustová's paper. So these are the first 3 lines. The last 3 lines show how Morphorita deals with lemmatization. This is accuracy of predicting lemmas. This is the accuracy of guessing joint lemma and part of speech. And the last one is, in many cases, one doesn't need the whole 15 position part of speech tag as it is proposed by Jan Hajic, but sometimes people only need the first 2 positions of the tag, which correspond to part of speech and sub part of speech. So if you train the model only on this restricted set, the results are better and it is much faster. Okay. These are the software parameters. So this is Morče, Johanka, Spoustova's implementation of the paper. Featurama, a previous research, and Morphodata. The first 3 lines is the same task, part of speech tagging. And this is, the greater is better, so word throughput. This is memory usage and model size on the disk. And the last line shows if you only need, like part of speech, the first 2 positions, the tagging is then much faster and the models are smaller. Okay? So this is about Morphodata, the Morphologic Dictionary and Tagger, and I will now move on to the next part of the talk, to the second part, which is named entity recognition. So named entity recognition, the task is to identify and also classify named entities, like proper names, and we distribute our tool also with trained models, so anyone can use it as it is, or the tool allows training custom models, like for people who study legal text or something. Okay. Just a quick detour. Okay. Or maybe I can do this. So I had a nice sentence. No, but I want it in Czech. Okay. Again, if you give the tool a raw input, raw text, it does segmentation and tokenization and then finds named entities. This is not nice to read, so you can use a pretty print. So this is, or maybe I can show it with the mouse. This shows it is the first name and second name. This is a date, the day, month, and year. Here, this is a geographical unit, and here we have a mistake of the tool because it's statistical. So when I tried it yesterday, I noticed it thinks that Hradeček is an institution. Okay, Praha is a geographical unit. That's correct. So we can go back. So again, the tool is available either as a binary library, a web service, or such a demonstration online. So what's the methodology? It's a re-implementation of a research by me from last year, and it's a supervised machine learning method. So it's statistical, and you can see it made a mistake. Well, it's not a rule-based, it's statistical, so that's what I wanted to say. Okay, for each word in a sentence, it does morphological analysis, and it uses the Morphologic Dictionary and Tagger, which I was talking in the first part about. And for each word, it extracts classification features. These are pretty much straightforward, what you would yourself be thinking about. Morphological analysis, so all kinds of things like what the form looks like, what the lemma looks like, what the tag looks like, orthographic features like capitalization and punctuation information, and so on. Then it uses two-stage prediction. That means it does, the tool predicts the named entities and then uses the output from the first round as a classification feature to the second round. It needs a set of gazetteers, or actually it does not need them. You can use it without it, but it improves the results. And we use brown clusters. Okay. This is a short scheme of how the tool works. So these are the classification features which are extracted from each token, and this is the first round. So a classification model, which is maximum entropy model, predicts for each word in a sentence a probability of its being all kinds of classes and position within an entity. That means if you have a word, the classification model says the probability, what is the probability of this word being the beginning of, say, a city? What is the probability of this word of being the last word in an entity, I don't know, first name, and so on. And having this this probability distribution, it is then globally optimized for the whole sentence. One could use the probabilities which are predicted by maximum entropy model right away as a classification tool, but the results are about 2 or 3 F-measure points better when one uses a global decoding. So we do global decoding for the sentence with dynamic programming. And this is the results from the first stage go to the second stage, and it goes once again all over. And that also adds some results. We were experimenting. We thought that we could use only the first stage output as the output of the tool, but we were losing some precision, and well, we were losing a lot of, so we had to do a two-stage prediction. And this is the evaluation. So the first 4 lines is the research in the past years. This is the very first paper published in 2007, and this line is the last year published results on Czech named entity corpus. There are 2 tasks in the corpus. You can either predict a fine-grained 42 classes, or you can try to predict an easier task, a more coarse 7 classes. And last year, these were state-of-the-art results, and our re-implementation is worse. We think it's because of implementation details, and yes, we were not able to re-implement everything. You might like to ask why we didn't provide this, but this was only a parallel prototype, and it was very, very slow and not not in a shape for publication to a wide audience. So this is a re-implementation in C++, and yes, so the numbers are slightly worse. And this is the second version of Czech named entity corpus, which I will talk about a little bit later. And we have unfortunately, we have no comparison here because it's very new, and I don't know about any other results on the second version of the corpus. So this is the F measure on the second version. Okay, and these are the parameters of the system. So the throughput is 40,000 words per second, and it does need 54 megabytes in memory and 3 megabytes on disk. This does not include 2 megabytes per morphologic dictionary. Okay. A few words about the release. I already said it, that it is available as a tool, C++ source code, web service, and online demo, and we try to make it as much available as possible. So the source code is available under Lesser GPL, and the models also for non-commercial use. Yes, and we hope this will be, and it is open for anyone from outside the institute. Okay. Now the last part of the talk is a few words about the Czech named entity corpus. For those of you who don't know about the first version of the corpus, I will just say in this one slide about the first version. It's a Czech corpus of named entities, and it classifies entities into two levels. It has 42 very fine classes, which are merged into 7 more coarse classes, and it does allow ambiguous labeling. That means for one entity, one can have two labels, up to more than one label, and it does allow embedding entities. And this is a little bit complicated for automatic processing, and our tool always only predicts one label, and it predicts the most outer entity, and it does not try to predict the embedding entities. So we are losing some points here. But also, I don't know about any other tool which would attempt anything else. The Czech named entity corpus, one was only a fix of known issues of 1.0, and now the second version. The second version contains over 32,000 named entities, and the greatest change is that the classification changed. So the task is considerably is different. Most noticeably, we added emails because we have noticed that people needed a separate class for emails, and we didn't have any at all. And some of the usages of numbers were merged because we had too many classes for numbers in the first version. So the resulting hierarchy is again Twolevel, and on the fine grained it has 46 named entities. The second great change, which I forgot to include in this slide, but I will tell you about it, is that there were sentences added. So it is larger, and we did this because we wanted the corpus to be more balanced. So there was a next round of annotation, and there were more sentences added. You can find more information here, and the changes are described in the documentation or online. Okay. So these are the three things I presented, and since I was talking very fast, I'm open to questions, or I can say more about the tools. So, okay, that's all.
So. Zdeněk?
I have a very simple question. You mentioned how you treat the endings in the morphological analysis, and I wonder, do you work the same way with prefixes, or you know what I mean? Okay.
Actually, you should know about this, or it's an interesting question, and it's also an interesting problem. We deal with the endings. So the prefix tree
is very well, say, built or made or designed for working with endings, with these suffixes. We don't have any like a clever or good trick to work with prefixes, and these are two bad prefixes in the Czech language, and that's ne and ne, and they act as their own lemmas, and there is just a hack to overcome this.
So the tool is as it is now, and you can use it for the core Slavic languages with many endings. And if there are more prefixes, then one has to think about it and make adjustments.
Okay, thank you. And one more question: what about the deep pronouns? If we take one of the pronouns, they do not have any overlap at the beginning. I mean, ho and nye, or on and nye. So the the common prefix is just an empty string. Don't you have troubles with that?
Yes, no, it acts as two separate things. It's two separate templates.
Okay, thank you.
So who wants the microphone?
Well, just a simple technical question. You said there's a version for Java. When is it placed in some public Maven repository?
I don't know, but we can see. I don't know, I'm sorry. Because I didn't do it, so I don't know Java.
GitHub. It's on GitHub. Yes, it's on GitHub. It's all on GitHub. Yeah. Okay, it's in the recommendation answer. I don't know, but the whole source code is on GitHub, and the language models are on main.carrier. What else? Yes.
Okay, thank you.
In this slide were the 4 results from Morphologic were on lemmas, tags, and bows, and only the core stack or part of speech. So these were retrained. The model is always retrained. And if you just take the full tag and evaluate only the first 2 positions, it will be lower score than this 99%.
Okay. Yes, the model was retrained. You asked if you train for the whole. Yes, I think I know what you asked, and I hope I know what you asked. And the answer is it was trained as if there were only 2 prefixes, and we discard the rest during training.
Yes. So if I only care about the first 2 positions of the tag, I should use a model trained specifically for this task to get the best results, yes.
Okay, and there are, I think, 3 or 4 models for both Morphologic and LingMon, and they differ on how good accuracy they give and how fast they are. So there is a trade-off between how fast the tool you want and how good results you want.
Okay, thanks. And can I get a few questions about the name tag? First, maybe for others, you said that you only recognize the outermost named entity, but there is also something like containers, and it was seen in the demo that the host name, first name and surname is recognized and both parts. So this is done by rules?
Containers are an exception from embedding because they are so much important. Like everyone wants to have first name, surname, and the container of the whole name. So we recognize the person container, and it is a rule. It's a post-processing rule. When it finds the first name and surname, it kind of envelopes it into proper name container.
Okay, but let's say if we have a name of a city and inside is a name of a river like Ústí nad Labem, then only the whole is tagged as a name of a city, and we cannot see that Labe is a river. Okay.
It's a river, and we were thinking if we should recognize the innermost or the outermost entity, and we made exactly the same thought that you just made, that one preferably, or we think that preferably you want to have the whole entity, and maybe one can do some post-processing or something, but the outermost entity is, to our design choice, the most interesting.
Okay, and the last question, do you somehow exploit during the training that there is 2-level hierarchy, that first maybe you can just train on the 7 classes and then refine it?
It's a very interesting question, and not only for, it is not an interesting question only from the point of named entity recognition, but also for people who annotate corpora, you know, we have just been looking into this topic. Is it more interesting to annotate 42 classes which are very fine-grained, and or 7 classes which are more like merged or coarse, and which is better for machine learning, and is it better to train on the 7 classes and predict the more coarse 7 classes, or to train on 42 and then you somehow extrapolate from these results the 7 coarse classes, and it is always a trade-off between the size of the corpus and the classification you made. And the best results we achieved were those when we trained on the fine-grained 42 classes, and then we reduced the model to 7 classes, because
Then, for maximum entropy, the context in which these 42 classes appear are very much informative.
So say you have a class, now which class appears in the 42 classes and not in the 7? I don't know. A street and the street versus a geographical unit in the course hierarchy, and you always see street in the same context. Like, I don't know, he lives in street number. So it is very easy for the maximum entropy classifier to learn. This is my hypothesis, but I'm just explaining what we received from testing the corpora, evaluating the corpora. It is easier for the classifier to find a direct connection, a linear connection between the context, always repeating context, than when it is a one class which has everything in it. So, what was the question again?
If you exploit the 2 levels in training, so you do.
Yes,
Okay,
yes.
thanks.
Have you tried any experiments with retraining Morphologic on other languages?
Yes, English. We train Morphologic for English because we want to submit the paper, which is now under review, and we thought that an English evaluation is very important, otherwise no one will read the paper. And what can I say? The English results, again, because it's a implementation of Vimaka Spust, much the same as in Vimaka Spust, only it's C++, and we make adjustments so that it is faster. And also the Morphologic Dictionary encoding is different.
Yeah, so if I wanted to retrain it on another language, I pick up and assume I don't have any morphological analyzer available for that language. So the only thing I have is the corpus with the tags, and possibly I know that there are positions similarly to the Czech tag set. So how difficult would it be to do that?
I should have said it because I also expected this question because we get it a lot. This is like maybe the first question one asks when they see this tool. What you need? A list with form lemma tag pairs and an annotated corpora with forms and tags. And lemmatization, if you want to do lemmatization, then lemmas. So you would need morphlex and a parallel to morphlex and a parallel to PDT, but only the morphological part, not the analysis trees. So the M trees.
Okay, so if I don't have a real tool for morphological analysis, I would just extract the pairs or triples from the corpus and say this is the dictionary, right?
Yes.
Did you try to measure what would it do to your check accuracy if you reduced the resources to that level?
Okay. Good question. And we are currently working on the request flows. What we have data for?
I think Slovak and Polish, and the next level would be Arabic, which we have dictionary for, but we just finished this and we want to continue with these languages. But it is a good question. How what will the drop of accuracy be if the dictionary is not a nice handmade, years developed, but if it is extracted from a large corpora?
Okay, thank you.
questions from the, I will say outsiders, but I don't mean outsider, but people coming from outside? Well, if not, so thank you very much for your presentation. Thank you very much for the discussion. And if I'm not mistaken, then the next session is next Monday, and Adam Kilgarif is coming to have a talk at the seminar. So you are most welcome. Thank you very much, and see you next week. Thank you.